Welcome to the deep dive. Today we're digging into airside economizers.
Right.
Think of this as your quick guide, really, to how these systems use outside air to cool buildings and save energy, of course.
Exactly. Free cooling. That's the core idea you'll see in standards.
So free cooling, basically letting nature do the work when the weather's right.
Precisely. They bring in outside air, provided its temperature and humidity are suitable, to help out the cooling load, sometimes even handle it completely. It cuts down on running the main AC.
Okay, so it's not always just about temperature. Humidity matters too. Our sources mention different ways they decide when to do this, like control strategies.
That's right. You've got controls based purely on temperature, like fixed dry bulb or differential dry bulb,
Okay.
and then more, let's say, sophisticated ones involving enthalpy or dew point, which account for moisture.
Right, enthalpy sounds familiar. That's the total heat content, temperature, and humidity combined.
Exactly. That's often recommended for humid climates, to avoid bringing in muggy air. Dew point controls work similarly, focusing on the moisture level.
But there's a catch sometimes. I think our sources mentioned that while enthalpy sounds better, maybe more thorough.
It can be less reliable in practice. That's a key point. The sensors can be tricky.
So complexity versus reliability makes sense.
Standard 90.1, it lays out specs for these controls.
Right.
There's even a table mentioned that focuses just on the dry bulb options. Things like setting a high limit, maybe 75 degrees air, 60 degrees air, 65 degrees air, if it depends on the climate zone.
So the economizer shuts off if it gets warmer than that outside.
Correct. Or differential dry bulb, where it compares the outside air temp to the air coming back from the building.
And the reason that table might focus on dry bulb, maybe simpler sensors.
That seems to be the implication. Building owners might prefer to skip the hassle of maintaining humidity sensors, which you need for enthalpy or dew point, but this table offers a simpler path.
Got it. And these aren't for everywhere, right? Generally not great for really hot, humid places.
Correct. Zone 1, typically not recommended, maybe limited use in drier parts of Zone 2, but, even where they are suitable, they have to actually work correctly to save energy.
Which leads us to the next big point. How do these things fail? Because a broken economizer isn't saving anything.
No, it could be costing you more. Malfunctioning dampers are a huge one. Modulate right or they get stuck open or closed, the whole strategy falls apart. Maybe the actuator is broken because no one's checked it in years.
So it's not bringing in outside air when it should, or maybe it's bringing it in when it shouldn't.
Both can happen.
Yeah.
Or maybe there isn't even a proper motorized damper to close off the outside air intake when the building's empty, except for specific modes like purge or, well, economizing itself. You end up with unwanted air infiltration.
Okay, so dampers need to work smoothly. What else? You mentioned sensors earlier.
Sensors are another major weak point. If they're reading incorrectly, giving bad data, maybe they're just off or way out of calibration.
Especially those humidity or enthalpy sensors.
Particularly those, yes. They need more attention. So the control system gets bad info and makes bad decisions. It might think it's cool and dry outside when it's actually hot and humid, or vice versa.
So garbage in, garbage out for the controls.
Pretty much. It comes back to that reliability issue with enthalpy controls if maintenance isn't kept up. Broken sensors, poor feedback. It all leads to wasted energy.
So design matters, and it sounds like maintenance keeps coming up.
It's critical. Lack of maintenance is probably the biggest killer of economizer savings. Regular checks, sensor recalibration, it's essential. A neglected economizer is often a failed economizer.
Let's wrap this up. Airside economizers. Potentially big energy savers using free cooling.
Right, when conditions are right and they're working properly.
We talked about control strategies, simple dry bulb, more complex enthalpy and dew point, and the reliability trade-offs there.
And the common failure points. Dampers sticking, sensors drifting.
And the big one underlying a lot of that, lack of maintenance.
Absolutely. Regular checks and calibration are key.
We also touched on limitations.
It really covers the life cycle, the potential, the pitfalls, and the support available.
So the final thought for you listening is maybe how crucial that ongoing attention is. These systems seem simple in concept, open a vent when it's cool outside, but making sure they keep working effectively takes real effort and understanding.
Definitely. Proactive maintenance and knowing your controls make all the difference.
Thanks for taking this deep dive with us today. Until next time.